Hi everyone, I'm M.Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Technology. Today I'm going to tell about what is multitask learning, which is a concept in deep learning and applications where a single AI model is trained to perform multiple related tasks at the same time. So a student can learn maths, science, English, and Gen AI, full stack like that. Together instead of learning only one subject, similarly a multitasking learning model learns several related tasks together. So before getting to the topic, gives you the recall of previous sessions like deep learning is a branch of AI where computer learns patterns from data using neural networks, and then single model multiple task, which is normally one AI model performs one task only. Example, one model for face detection, and then shared representations. Here this model shares knowledge between tasks. If the system already learns eyes, nose, and then face shape likewise. So this reduces training time, memory usage, and computational cost. And the last one is task specific outputs. Even though the model sash knowledge intentionally, check each task produces its own final result. So objective of today's session is students should understand what multitasking means, why it is useful, and where it is used here. Here, training a single model for multiple related tasks instead of creating many separate models, one combined model is trained. Example, in a smartphone camera, face detection, smile detection, age estimation can all happen together. And then improve overall model performance means when tasks are related, they help each other but learn better. Example, learning face detection can improve emotion detections, and then reduce training time and resources. Here, use separate models requires more memory, more CPU or GPU power, more training time and all. Here, uh, understanding in real world applications, many related tasks need to solve together. Example, a self driving car must detect roads, identify pedestrians, recognize traffic or rules signs, and estimate distance all at the same time. Here, issue with a separate model is if a separate model are used, each model must be trained individually. Each need memory and computation, and maintenance becomes difficult. So this cause high cost, and slow processing, and increasing complexity. Here, here a solution for this idea is instead of many separate systems, use one intelligent system capable of handling all tasks together. So this is the idea behind multitasking. So here the complex problem here is managing many models becomes difficult. And also it has the higher resource computation. So each model requires memory, processing, storage likewise, and also there is a difficult to maintain and scale. So here the defined part is high development time. Building separate model take more coding, more training, more testing. So increase computational cost, which means more electricity, more GPU usage, and more training time. So this motivate the use of multitask learning here. So effective solution is equal to multitasking learning. So this idea is use one model for all tasks. Here, instead of many separate systems, combine all related tasks into one network. And here, hidden layers improve patterns for image processing, edges, shapes, textures. So these features are useful for many tasks. So the layers are also shared. And here use separate output for each task. Although learning is shared, each task has its own output layer. And here the main benefit is faster, cheaper, and smarter because tasks help each other learn. So multitasking is a single neural network. It accepts input, it shares through the hidden layer, produce multiple outputs. So simple example, input human face image and shared through the facial features. Different outputs are there: person identification, emotion detection, and gender prediction. So why shared learning works? Here, related tasks often use similar informations. Example, eyes and mouth features are used for face recognition and mouth recognition detection. So sharing knowledge improves efficiency. So what are the types of multitasking here is, first one is hard parameter sharing. Here it means same hidden layer shared, separate output layers are there. And then soft parameter sharing is separate models, parameters encouraged to be similar, provides flexibility. And then third one is multi-head architecture. Here one shared backbone, multiple task specific heads, very popular in computer vision. And the last one is hierarchical multitasking learning. Simple tasks help learn complex tasks. Tasks are arranged in levels. So a small definition in hard parameter showing. So here all tasks share here the same hidden layer in same hidden layer, but each task has its own output. The advantage of hard parameter sharing is fewer parameters, reduce overfitting, and better feature learning. And then second type is soft parameter sharing. Here each task has its own separate model, but parameters are encouraged to remain similar. Here a mathematical technique called regularization, it is used to keep model related. Here the benefits are learn independently, still share knowledge, and this gives better flexibility and customization. And here also limitation also here, because it has a each individual structure. So here more memory and more computations are used here. And the third type is multiple head architecture. So this backbone extract important feature. Here each head perform a different task. In autonomous driving car Tesla, one head detects cars, another detects pedestrians, another estimate land position, and all using the same input image. Here the advantages are here is future extraction happens once, many tasks are solved together here. And the last type is uh, here the lower level task help higher level task then better. Example in language processing is it is simpler task, intermediate task, advanced task are there, and benefits are complex tasks become easier because foundation knowledge is already learned. And this is the training network. Here feed the same input data to shared layers. So the same input is given to the shared layer, and then each task calculates its own error. This error is called loss function. And third one, all task losses are added together into total loss, that is total error. And then model adjust by shared layer, task specific layer simultaneously. And then weight, some task may more important, example weight. And then this slide shows the advantage and limitations of multitasking learning. And this shows the what are the applications in multitask learning, like face detection, recognition, emotion detection, object detection, medical diagnosis, NLP, and last one. So multitask learning is a deep learning technique where one model perform multiple related tasks together. So why it is important is it saves time, it saves memory usage, it improves accuracy, and it simplifies simple designs. And here the core concept here is shared learning plus separate outputs. The model shares common knowledge and produce task specific predictions. Thank you. Hope you understand this session. Thank you everyone.